Okay, and let's revisit the unit circle approach. Again, it's a convenient approach if you want to memorize ordered pairs around the unit circle in an attempt to memorize sine and cosine values. However, it's not necessary. R can be arbitrary, and the point Pxy can be any point on the terminal side of the angle other than the origin. But again, if you are taking a unit circle approach, then you're deliberately letting the distance between the point xy and the origin be a value of 1. Let's take a look at this in light of special triangle. Okay, for example, these two pictures are identical, but try not to let the scaling throw you off. If I were to make this the 30, 60, 90 right triangle and its proportions, the natural thing for me to do would be to let the hypotenuse value be 2, and then the side adjacent 60 degrees would be 1, or half the hypotenuse, and then the third side would be developed from the Pythagorean theorem. And in this world, your ordered pair P would be the ordered pair 1 comma root 3, and you would note that R is 2. So if you calculate the cosine of 60 degrees, for example, it would be the x-coordinate divided by r, and the sine of 60 degrees would be the y-coordinate divided by r. Now likewise, if I were to do the same thing, but instead deliberately choose to cut down the size of the triangle and allow the r value to be 1, then this would mean that the side adjacent 60 degrees is half of that, and then using the Pythagorean theorem we could calculate the third side, and you should try that on your own to make sure you can do it. And in this world, our ordered pair P would be the ordered pair 1/2 comma root 3 over 2 with an r value of 1. But notice the effect is the same. The triangles are similar. Cosine of 60 degrees is x divided by r, or simply x if r is 1. And sine of 60 degrees is the y-coordinate of the ordered pair divided by r, or simply the y-coordinate since the r is 1. And you see that the trig function values are the same. If I put these in line with each other, what you're looking at is the following. Okay, and here's what I mean by the triangles are similar. You can see that the angle theta, again not drawn to scale, but in standard position is 60 degrees. And in the first triangle, the distance between the origin and the ordered pair here is 1 unit, but in the larger triangle, let the distance be 2, and then what would follow proportionally would be the values we discussed a moment ago. So in the bigger triangle, your sides, the other two, are 1 and root 3, and again r is 2. But in the triangle where I've forced r to be 1, I'm cutting all the sides down by a value of 1/2, and my ordered pair here would be 1/2 comma root 3 over 2 with r equal 1. And so we get really the same trig function values. So our trig guys are what we call well defined. Any legitimate version of 60 degrees in standard position using the special triangle arrangement will work for us.